Okay, we have another limit question here. First, if we factor both the numerator and denominator, then that's going to be x 2x minus 3, x plus 2, 2x minus 3, right? So 2x minus 3 cancels out. So this is equal to limit as x approaches negative 2 from right hand side, x over x plus 2, right? Now if we substitute negative 2 for x, the denominator will be equal to 0, but not the numerator, right? Then this function right here has a vertical asymptote at x equal negative 2. So far so good? So let me draw xy plane. So here's a negative 2, and we have a vertical asymptote, right? X approaches negative 2 from right-hand side, right? So I'm going to assign a value of x little greater than negative 2, maybe negative 1.99, right? So if x is negative 1.99, negative 1.99, you don't have to evaluate this expression when x is negative 1.99. All we have to know is whether this is negative or positive. So negative 1.99, that's negative. Negative 1.99 plus 2, that's a positive, right? So negative over positive, that's negative, right? That means this expression is a very large negative value. In other words, as x approaches negative 2 from right-hand side, the function value will approach negative infinity. If we graph it, it's going to be like that, right? So the answer is negative infinity.